Okay, so we will start from where we left in the last class. Okay, so this is again something that you would have seen in 10th class, and then we also saw this last class, right? So for all elements in the real number set, sine square x plus cos square x is 1. Okay, so this is okay. Now, you also have two other identities which are based on this, right? Do you recall those? Anyone? Okay, so you have two more identities which are derived from this identity.
Sir, it would be 1 plus tan, sorry, sir, 1 plus cot.
Okay, even tan is okay. 1 plus tan square x, that is also okay. 1 plus cot square is also okay. Okay, so on the other side, what do you have?
1 plus cot will be equals to cosec, sir, cosec square.
Very good, cosecant square. And then 1 plus tan square x?
It will be, uh, sir, sec square A, sir.
Very good. Okay, so we know this. Okay, so if you divide both sides by cos square x, we have sine square x by cos square x, and then plus cos square x by cos square x, and the right hand side you have 1 by cos square x. So this will give us the sine square x by cos square x is tan square x, and then this is just 1. Okay, and then the right hand side you have a secant square x. And instead of dividing by cos square x, if you divide both sides by sine square x, you'll get sine square x by sine square x plus cos square x by sine square x. And the right hand side you have 1 over sine square x. So sine square x divided by sine square x, that is 1. And then you have, what did I write? Cot square x. Guys, I'm not trying to frighten you. This is just 2, don't worry. Okay, I don't, that is 1 plus cot square x is equal to cosecant square x. Okay, so I think, yeah, we have these identities in 10th class as well. So we are just looking at them again. Okay, and x can be any real number. Okay, so in 10th class, I think we may get that idea, we may not get that idea. Okay, because we are only restricting ourselves to angles in a right angle triangle. But here we are going beyond that. Okay, so you have 1 plus tan square x is secant square x, and then 1 plus cot square x is cosecant square x. Okay, now look at this, guys. So now what we are trying to do is we will look at some of these angles, and then for each of those angles, we will try to look at what is the value of sine, what is the value of cos, and then what is the value of tan. Okay. So now look at the arrow here. Because the arrow is pointing towards A, we are saying that the particle is at this position on the x-axis. So the angle made by this arrow with our reference line is our x-axis. So that is 0. Okay, so for this point, the coordinates are 1 and 0. And then yesterday we saw that we take the value of x coordinate as the value that the cosine function gives us, and the value of the y coordinate is the value provided by the sine function. Okay, so sine of 0 would be 0 here because the y coordinate is 0, and then cos of 0 will be 1. And now we know that tan is defined as sin x by cos x. So tan x is sin x by cos x. So sin 0 is 0, cos 0 is 1. So tan will be, what will be the value of tan 0? Guys, I think there's a lot of disturbance here. Yeah, what will be the value of tan 0?
0 would be
0 by 1.
0, sir. 0,
0
sir.
by 1, so that would be 0. Very good. So now let's move on to a different angle. Okay, so now we'll move to pi by 6, which is 30 degrees. So here I have marked the coordinates of this point P. So what will be the coordinates? X coordinate will be half and Y coordinate will be root 3 by 2. Okay, so X coordinate gives you the value of cos, Y coordinate gives you the value of sine. So sine pi by 6 will be half, cos pi by 6 will be root 3 by 2. And then if I divide these two, I'll get tan, which is 1 over root 3. I think this is okay.
Yes, sir.
Yeah, so we'll move on. Okay, we'll keep going. I think this should work as a refresher basically. Okay. And the next angle is pi by 4. But here, what I'm trying to do is I'm trying you to appreciate the fact that this cos and sine are basically the x and y coordinates as the point moves along the circle. So now we have reached 45 degrees, okay, which is in radians pi by 4. Both the x coordinate and the y coordinate are equal to 1 by root 2. So your cos pi by 4 will be 1 by root 2. Sorry, sine pi by 4. And then cos pi by 4 is 1 by root 2. And then tan pi by 4 is 1. Then now we'll quickly jump to 90 degrees. Okay, so if you move to 90 degrees. Why did I say 90 degrees? You have one more important angle, right, between 45 and 90. So we have pi by 3, which is 60 degrees. So cos pi by 3, sin pi by 3 is okay. Guys, do you see a mistake that I made here in the slide?
It should be cos instead of sine.
Yeah, I think I need to correct it. Okay, now have I rectified my mistake? So sine 60 degrees is root 3 by 2. Cos 60 degrees, which is cos pi by 3 is 1 by 2. And then tan will be a division of these two. So you will end up having root 3. Okay, I think we're okay here.
Yes, sir.
Yes, sir.
So see, these things I'm trying my best to type them down quickly. Some days I get time to review them nicely. Some days I don't get. So yeah, you have to bear with me. So now go to 90 degrees. So now you have x coordinate 0 and y coordinate 1. Because y coordinate is 1, okay, sine 90 or sine pi by 2 will be 1. And cos 90 or cos pi by 2 will be 0. And then what is tan here? What is tan 90? Anyone?
What, sir?
It's not defined.
Very good. Tan 90 is not defined because we don't want to divide anything by 0. So 1 by 0 is not defined. Fantastic. So this is not defined. And then now let's go to another angle. So now we are quickly switching to pi. So here the x coordinate is -1 and the y coordinate is 0. So sine pi is 0 and then cos pi is -1. And then if you take tan, I'm making another mistake. So this should be tan pi. So I'll correct these later. So for the moment, I'll take it as tan pi, which is again 0. Okay, now we are jumping to 3 pi by 2. So what is the value of sine 3 pi by 2? So that is -1. And cos 3 pi by 2 is 0. And then if you divide them, again, what should we get here, Sudhanya?
Not defined.
Not defined. Fantastic. So this is also not defined. And then if you complete the circle and then come back to point A, we are again back with the same sine and cos values, and of course the tan. Okay, we are okay. I think what we need to really appreciate is we are going around the circle. We can go around the circle as long as we wish to. Okay, there is no need to stop at 2 pi radians. So you can start the journey again, go around the circle and then complete 4 pi radians, and then again go and then complete 6 pi radians. So what is that what is happening really here? The values that these functions give us, sine, cos, and tan, they repeat. You guys understand? So they repeat. So for every revolution, they repeat. And then slowly we will see that if you look at 4 of these functions, okay, so sine, cos, cosecant, and secant, the values that these functions give out, they repeat after every revolution. Okay, so that means after every 2 pi radians, the values repeat again and again and again. Okay. But when it comes to the tangent function and the cotangent function, tan and cos, they repeat every half a revolution. Okay, so every half a revolution, they have the same set of values. Okay, so their repetition pattern is a little different from the repetition pattern for sine, cos, cosecant, and then secant. Okay, so these things again you need to appreciate. Okay, so I'll show you that. I'll show you in a graph. Okay. And another thing that you need to realize is we have chosen angles which are very convenient. Okay, there could be many more angles which are not nice. Okay, so in between, let's say maybe a 15 degrees, or maybe a 17 degrees, 75 degrees, 17 degrees will be even harder. But later on, we will see how to deal with, let's say, angles like 15 degrees, 75 degrees, and so on. Guys, what is happening is there is a cart that is moved around here, a trash cart. Are you hearing that noise, or you're only able to hear me?
No, sir. No background was only you.
Achha, you're not getting any background noise, right?
Yes, sir.
Oh, that is nice. So my little buddy is good here. I'm using this Blue Yeti mic. Do you see that?
Yeah, sir. Yeah.
Yeah, that is cutting off the background noise. That is nice. I was worried if it is picking it up.
Yeah, no, sir.
Okay, nice. That is nice. Okay, so now let's continue. Okay, so now remember we said if you move in the counterclockwise direction, your angles are positive. Okay, so if you move in the clockwise direction, your angles are negative. So now what we want to do is your input. Okay, so for sine or cos, your input can be positive values or your input can be negative. So it can be plus x or it could be minus x. So in that case, how do you deal with it? Okay, so look at this closely. The x coordinate doesn't change. Okay, x coordinate is still a, but there is a change in the y coordinate when you go from x to minus x. So this point P, the y coordinate here is B, but when you go in the clockwise direction, the angle covered is minus x, the y coordinate becomes minus B. So from B, it will become minus B. So in that case, what can we say? Sine of minus x is minus B, but we know B is sine x. So what are we saying? Sine of minus x is minus sine x. Are we getting this? Okay,
Yeah,
so
sir.
if your input is minus x, all you have to do is you can operate on x, but whatever value you get, you take minus of that. For example, if this x is 30 degrees, if x is 30 degrees, okay, which is equivalent to pi by 6, we know if you do sine pi by 6, you end up having half. Sine of minus pi by 6, you are actually getting into the fourth quadrant. So your sine value, because it is given by the y coordinate, it is negative. So sine of minus pi by 6, you will just say that it is minus sine pi by 6, and then you will get that as minus. Okay. But your cos of minus x will still give the same value as cos x. So cos of minus x is still a, which is as good as cos x. Okay, so this property, yeah, it is simple to understand, but it is a very important property. Okay, are we guys okay?
Yes, sir. Yeah.
Yes, sir.
Okay, so let's move on here. Okay, so now let's look at the range here. So we are looking at the range. So if a particle goes around the circle, what are the values that, let's say, the x coordinate will take? The x coordinate, we are saying that this is a unit circle. The maximum value of x on the circle will be here, +1. The minimum value is -1. Okay, so only the values between -1 and 1 are allowed. Okay, so A, which is the x coordinate, will be between -1 and 1. Both -1 and 1 are included. So it tells us that because the x coordinate is given by the cos function, so the range of cos function. Okay, so the range of cos function is between -1 and 1, both included. Okay, so similarly, if you look at the y direction, the y coordinates of the point will be between +1 and -1. Okay, so both +1 and -1 included. So the range of sin x should also be same. Okay, so it's between -1 and +1, both included. Okay, so now let's look at this. Okay, in the first quadrant, guys, can I say if you take any point, the y coordinate will be positive. Okay, so if you take any point, the y coordinate, let's say I'll put x comma y. So your y coordinate will be positive, x coordinate will be positive. So that tells us that sin x is positive and cos x is positive. And then I don't know, I think sometimes students try to remember this, but you don't have to use any memory techniques here. You just know that your sin and cos x are basically x and or y and x coordinates. And you know in the first quadrant, they are positive. If you go to your second quadrant, what is going to happen? Your x coordinate and y coordinate. Your y coordinate is still positive. Your x coordinate is
minus plus, sir.
That's it. Exactly. So if you go to third quadrant, what will happen? Both will be
Minus.
right. And then how about fourth quadrant?
It would be plus minus.
Plus minus. So your x is plus and then y is minus. If you just understand this, you don't have to remember anything. I think your other trigonometric functions are anyway based on these two functions. Okay, so your tan is based on these functions, your cot is based on these functions, cosecant and the secant are based on these functions. So you can get this sign. Okay, so it should not be a big deal once you get this idea. So in the second quadrant, sin x will be positive because it is the y coordinate. Cos x will be negative, okay, because it is the x coordinate. And then if you go to third quadrant, both are negative. Okay, and then if you come back to fourth quadrant, your sin x is negative, but your cos x is positive. I think this is okay, right? Then now we are looking at graphs. Okay, so this is again, I took the help of Desmos to graph this. Now, as the particle goes around the circle, you look at this. The values continuously increase. Okay, so it goes from 0 to pi. That means you are, while the particle is moving in the first quadrant, the value of sine is going from 0 to 1. And in the second quadrant, what will happen? It will drop to 0. And now in the third quadrant, it will go to -1. And then again, by the time it comes back to the same point, it will be 2 pi. And then there is a continuation. Are you guys getting this? So this pattern repeats. So whatever you see here, so this pattern repeats. You're okay with this graph?
Yes, sir.
And
Yes.
and I think this is very, very important when you learn simple harmonic motion. This appears all the time, okay, and in waves also. Okay. So Sudhanya will tell more about waves and simple harmonic mechanics, right, Sudhanya?
Yeah.
Yeah. So these things are extremely useful there. So now let's look at the domain. What is the domain here? Domain, all real values are allowed, acceptable. So the domain is the set of real numbers. But if you look at the range, what are the output values that we are getting? We are getting from -1 to +1. That's it. You don't have other values. So the range is between -1 and 1. I'm using the interval notation here. Both 1 and -1 are included. And remember what I said, for every 2 pi radians. So if you look at every 2 pi radians, the values are same. Okay, so if you look at from here, okay, so every 2 pi radians, the values are same. Even if you go another 2 pi radians, the same set of values will be repeated. So that is why the period is 2 pi. Okay, so if they ask you what is the period of this sine function, then that will be 2 pi. Okay, so every 2 pi radians, you will end up having the same set of values. The sine function will give you the same output values. Now, let us look at the cos function graph. Okay, cos at 0, you have the maximum value, right? And then after that, it is almost like your sine function, but yeah. In the first quadrant, the values will drop to 0. And in the second quadrant, they will again drop. They're actually dropping because they become negative, right? So they're dropping and then becoming -1. And then again, they start to rise. Okay, so they will become 0 and then again +1. So this is one complete cycle. Okay, so this is one complete cycle. I've only taken one cycle here. So the domain is again, all the x values are acceptable. So the domain is R, and the range is again like the sine function. You have -1 and 1, both included. All the values in between are also included. And again, the period is also same as the cos function. You can see that here. Okay, I have only 2 cycles given here. So you have, let's say, for every 2 pi radians, this get repeated. Are we okay, guys?
Yes.
Okay,
Yes,
any questions here? I want you to appreciate these 3 things, okay? I mean, first thing is the curve, and then what are the acceptable values, which gives you the domain, and the range, and the period. Sorry, guys, I'm having coffee. Huh?
Yes.
See, during my class, you can feel free to eat, drink. We're all allowed, okay? So, are we okay here?
Yes, sir. Okay.
Okay, now let's look at the cosecant function. So now this is how do we understand this? Okay. See, your cosecant is what? Cosecant is 1 by sin x, isn't it? 1 by sin x. Now, guys, can you reflect why we don't have any values here between these two? Why?
sorry, sir, I didn't get that. Could you repeat that?
Yeah, what I'm saying is, for the cosecant graph, there are no values between 0 and 1. Why do 0 and 1 and then 0 and -1? Why is that? Why? Can you think of a reason why?
The parabolas are not intersecting
No, no,
that
no.
x
These are not parabolas. No, no. They look like parabolas. They are not parabolas. Okay, let me explain. Okay. Now, in the previous, I think one slide before, what is the range? See, the values of cosecant x depend on sin x, right? What values can sin x take? It will take between -1 and 1, isn't it? Are we okay here?
Yes, sir.
Okay, now think about this. When sin x is going from 0 to 1, let's say, if sin x is going from 0 to 1, suppose, if sin x is going from 0 to 1, what will happen? Let's say sin x, can it be 0? Sin x, can it be 0? Is 0 allowed? Can I take
Sir,
sin
it
x to
cannot
be?
be. It would be undefined if sin x was 0.
Very good. If sin x is 0, it is not defined. So we are not going to take that. So that means we have to take a number which is just greater than 0.
Yeah, sir.
Now tell me, Harsha, if you take a number which is slightly greater than 0, what will happen to 1 by that number? If you take a number which is slightly greater than 0, what will happen?
It would not be undefined, sir.
It
The
would not be
value would be
undefined.
1.
Okay,
Yeah.
but how small or how big that number will be? If I'm dividing 1 by a number which is close to 0.
Okay.
It
It
would be in
would be
decimal.
greater than.
It will be how much? Let's say I'm
It
saying
would be greater than 0, sir.
greater than 0, but how greater? Let's say we will try to do one thing. Okay, we'll try to do one thing. So suppose if I divide 1 by 10, I'll get what? 0.1, right? But this
Yeah.
is completely ridiculous, right? We will never get sin 10, right?
Yes, sir.
So this is bad. Okay, I should not be giving that example at all. Okay, but let's say I'll give 1 by 0.1. What will this be?
It would be 10 by 1.
It will be 10 by 1, so 10. How about 1 by 0.01?
It would be 100.
It will be 100. How about 1 by 0.001?
That's 1000, sir.
1000. How about if I put another 0 here, what will happen?
Where, sir?
Here, between the decimal and the 1.
Then it would increase to 10,000.
So now do you see, when is sin x 0? Sin x is 0 when x is 0, right? So that means when you actually get very close to 0, what is happening to the values of cos x, cosecant x? They become very large. That is why this curve is shooting up. Are you seeing this? Are you able to notice this?
Yes, sir. Yeah.
You understand? So when x is close to 0, your sin x is close to 0. But if you divide 1 by a number which is close to 0, you'll get a very large value. That very large value is our infinity. That feeling that it's a very large number. You guys understand? I think Sudhanya got the point.
Yes, sir. It makes sense now.
Yes? Yeah. Om, you understand? See,
Still
if
little bit, sir.
little bit. Okay. See, if you are coming very close to 0, that means it's a number very close to 0, means it could be any of these numbers, right? You can say that it would be like a number 0.0000001. I can put many zeros. In that case, what will happen if I take 1 over that? I'll get a very large number, right?
Yes, sir.
So that would make your output of cosecant x very large. Understand?
Yes, sir. Yeah.
And you know the same thing happens when x becomes x gets closer to pi, right? When x gets closer to pi, also your sine becomes 0. Sine of 0, we saw it is 0. Sine of pi, which is sine of 180 degrees, that is also 0. So at these two places, you are getting a value sine x 0. But if I take sine x 0, I'm in trouble. Okay, so that is why if you see the domain, I think you look at the domain. In domain, I'm actually restricting. I'm saying I can take all real numbers, but I cannot take, I'm subtracting. I cannot take the x values when x is pi, 2 pi, 3 pi, or minus pi, minus 2 pi, minus 3 pi, because all these values will make our sin x 0. And we don't want the sin x to be 0. You guys catch the idea?
Yes, sir.
Okay, so that means what is happening whenever your sin x is 0, that is not acceptable. Okay, so that x value is not acceptable, but the x values which are closer to that, they are okay. Okay, so they are acceptable. But when you actually use those values, your 1 by sin x value will become very large. Okay, it will become very large. So that is why you see that at closer to 0 and closer to pi, you are actually getting a very large value for cosecant x. You guys are getting?
Yeah.
Okay, now another interesting thing happens. The moment pi is not allowed, okay, pi is not allowed, but the values which are, or maybe we can just first look at the 0 only. Okay, let's look at 0. Okay, let's look at 0. This 0 is not allowed. Okay, so we don't like 0 here. Okay, because that will make sine 0. But the x values which are on either side of 0, they are okay, right? Are we getting?
Yeah.
So now let's, this is, we'll go slowly, guys, because initially this is a hard idea. Let me put that unit circle here again. Now, what am I saying? If you are very close to 0 on the positive side, your sine value will be positive. Okay, but it will be very, very small. And if you are on the other side, here it will be negative. But the numbers which are closer to 0 and negative, they are considered kind of magnitude wise, they are small, but numerically they are bigger than, let's say, -3, -2, and so on. That we understand. But magnitude wise, they're still small. But we are on the negative side. When you divide by such a small number, you end up having a very huge number in magnitude, but it will still be negative. You guys understand this? So I'll take an example. Okay, I'll take an example. When you are to the left, okay, so when you are to the left of 0, it is like dividing 1 over 0.000001, but with a negative sign. Array, what happened? Okay, so I think maybe this is a good sign. Okay, we will discuss this again. So Harsha, see, what I'm trying to do is, when you are actually near 0, you can approach 0 from the left, or you can approach 0 from the right. Okay. Now, when you are approaching 0 from the right, suppose, if you are approaching from right, I am actually dividing 1 by, let's say, a very small number, 0.000. I'm just taking this as an example. So this will be a very large number, right? So we just say that very large numbers are just called infinity. Okay, so that is a feeling. So we'll just say plus infinity. Now, if I'm looking from the left side, if I'm to the left of 0, I still have a small number like this, but I have a minus sign to carry with it. Okay, so 0.000001. So now I'll still have an infinity, but it is a minus infinity. The meaning here is like this is a very large positive value. Okay, so this is a very large positive value. This is very large. You cannot say large negative value. It is very small negative value because you're putting a minus sign. The integer wise, it becomes very, very small. Okay, so you say that this is a very large value and this becomes a very small value. Okay, very small, very, very small. It's a very, very, you can say very as many times as you like. You guys understand this idea? Are we okay, Harsha? Okay, oh, are you guys there?
Yes,
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 sir.
sir.
I know, guys. These things they're not just troubling you. When I studied this, I was also shocked. I took a lot of time to understand this. Sudhanya might have had the same experience. Sudhanya.
Yes, sir, pretty much. Now that I'm getting like a refresher, I understand it more.
Yes. See, so we don't have to worry. I think as you spend more time, so they will become easier. But do you guys understand what is happening around zero? Harsha, you get this?
Yes, sir. Yeah.
So again, I'll repeat it again. If you are on the right side of zero, very close to zero, you're basically dividing because your cosecant x is 1 over sine x. So you are actually taking a value which is very, very small, x value. When you take very, very small value, your sine x will also be very, very small because you're in the unit circle. If you see, if your angle is very close to zero, that means you're almost on the x-axis. So the point is near x-axis. So your sine x value, which is nothing but the y coordinate, is still close to zero. Okay, so that is why I'm using, for example, 0.00001. Now, if you divide 1 by such a small number, you get a very large number. So that is why in the graph, you see that on the right, the cosecant x values are like huge. They go to infinity, they shoot up. Okay, as you get closer to zero, they become very large. The same thing happens when you are on the left side. Okay, so the values will become very, 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 very small. Okay, so they kind of shoot down now. Now, the same thing keeps happening wherever your sin x is zero. Okay, so wherever your sin x is zero, the same pattern repeats on the right side, on the left side. Okay, now wherever your sign is, let's say positive, you'll get a plus infinity. Wherever your sign value is negative, you'll get a minus infinity. The same thing happens around pi, right? So pi, you know, if you are in the second quadrant, that means when are you in the second quadrant? You are just to the left of pi. And then that is why you see very large cosecant values. Now, when you are in the third quadrant and then close to pi, your sign values will be negative. And that is why you see that you have a very small value. So you get minus infinity. And again, when you come back to pi, it's like zero. So again, you have positive and the negative. Now, in between, what is happening? The reason why you don't have these values is the minimum value of cosecant x is when you take sin x values positive. When you take sin x values positive, because you are dividing sin 1 over sin x, the minimum value of cosecant x will be 1, right? Because your sin x values are assuming sin x is positive. Let's say if sin x is positive, it is between 0, but 0 is not included. We don't like 0. And then sin x and then 1. Now, when you put sin x as 1, that is when your cosecant x is 1. After that, if you take any value which is less than 1, you will start getting greater values. Okay, so when as you approach 0, you will get very large values. So that is why between 1 and minus 1, there is no output from cosecant x. Om, you understand why?
Yes, sir.
Okay, Harsha, are you okay?
Yeah, sir, I'm okay.
Okay, so the same thing you can argue between why you don't have values between 0 and -1. Okay, and again, I'll leave this for you guys to explore. Okay, and now here again, if you see, the period is still 2 pi because you have negative values here and then you have positive values. So one complete, let's say, you say that complete values of cosecant x will be in the range of 2 pi. Okay, so in 2 pi, every 2 pi they keep repeating. So the domain is this. Okay, so the domain is all real numbers, but you don't like whenever sin x becomes 0. So x cannot be n pi, where n belongs to any integer. Okay. The range is, now we have seen all real numbers are given by this function except the values between -1 and 1. Okay, so those values are out of the range. You can say out of range, yeah. And the period is 2 pi. Okay. Now your secant x is similar to this. Okay, so if you look at secant x graph, you have a similar shape, but yeah, it is slightly shifted. Okay, so if you take your sin x and cos x graphs also, they are slightly shifted. Even the secant x graph is slightly shifted compared to cosecant x. But the same pattern you can see wherever, because secant x is what? 1 over cos x. So here again, because you are dividing by cos x, we don't want to take x values where our cos x becomes 0. When does cos x become 0? Remember those pi by 2s. Okay, whenever x is an odd multiple of pi by 2, my cos x becomes 0. When cos x is 0, my secant x is not defined. So we will leave that. But again, if you are getting closer to that pi by 2, let's say you're getting closer to pi by 2, it depends. Are you really coming from the left side or to the right side? Okay. If you are coming from the left side to pi by 2, so that means you are still in the first quadrant. If you are coming from right side to pi by 2, that means you are in the second quadrant. Now you know that in the first quadrant, your cos values are positive. In the second quadrant, your cos values are negative. So when you divide by a very small number, because when x approaches pi by 2, your cos x approaches 0. Guys, this approaching idea is very important. I'm trying to hit on these ideas, very important, because later on we will study something known as limits and derivatives. Okay, and that is hugely important for you. So this is where this idea is important. So if you are around that pi by 2, the pi by 2 is not acceptable. Okay, so that is a no-go zone. Okay, we don't want pi by 2, but we can take values which are close to pi by 2. Now, when you say what values are close to pi by 2, there are values which are to the left of pi by 2. There are values which are to the right of pi by 2. So I can take any of those values. But what is happening to cos? If you are coming from left side towards pi by 2, your cos values are small, but they are positive. If you are coming from the right side to pi by 2, again your cos values are near 0, but they are negative. So that is why your secant values to the left of pi by 2 will be very large. So you can say that they'll become plus infinity. But when you come from the right side, you get minus infinity. So there is an interesting thing, right? Just around that one point, आपके values positive से very large positive से very small negative values बन जाते. This is like ऊपर is immediately नीचे. Okay, this is called something known as a discontinuity. Graph में इधर क्या है? Continuous नहीं है. If you look at the sin x and cos x, they are nice continuous graphs. But अभी ये cosecant x and secant x, they are गड़बड़ graphs. I mean, you can say they are discontinuous. Okay?
Okay.
Are we okay here?
Yes, sir. Yeah.
So there are breaks. Okay. But anyway, I think again, for each graph, pay attention to these ideas like, okay, my domain again, I don't want x values wherever it becomes 0. The cost becomes 0. So the odd multiples of pi by 2, I'm ignoring. Other than that, all real numbers, all values from the real number set are okay for me. And then the range is same here. Okay, it's like cosecant x. It is going to give us all the real values except values between -1 and 1. Okay, so you see this is like a no output zone. Okay, you don't get any output from here. And when it comes to period is again 2 pi here, because if you see, let me point out here. So if I look at this region, that is a gap of 2 pi. Okay, so and again, if you go another 2 pi, you see that the same repetition is happening. The same pattern is getting repeated. Okay, so the same pattern gets repeated. Okay. Okay, I think I'll pause here for a minute. Guys, let me know if you have any questions. I know this is too much to take in, but yeah, watch this again and play with, if you have, I think, play with these graphs on Desmos or GeoGebra, whatever you like. Okay.
Okay.
So play with these graphs and understand more. I think there are many tools online. You can graph them and then see how they are varying. Okay, are we okay?
Yeah.
Okay, so let's move. Yeah. Now tan x. Now this is again interesting. Okay, so what is happening here? So tan x is what? Tan x is cos x. Sorry. What is it? Sin x by
Cos x.
cos x. So again, what values we don't like here?
Cos x being 0.
Yes, we don't want cos x to be 0. So when is cos x 0? Cos x is 0 whenever your x is a
Odd.
integral multiple of pi by 2, right? So that is why again you see there is a discontinuity around pi by 2s. Okay, so pi by 2, 3 pi by 2, all integral multiples of pi by 2, you see a discontinuity. That means you see a break. Okay, now here see, I'll show you the break here. So the same logic holds good. Okay, so the same logic holds good at every multiple of pi by 2. Here, if you approach from the left side and the right side, okay, so you know that the moment you approach from the right side, your cos becomes, sine is positive both in the first quadrant and the second quadrant. But when it comes to cos, first quadrant it is positive, but in the second quadrant it is negative. So the moment you approach pi by 2 from the right side, that means you are in the second quadrant, your tan values will become negative, but they're actually becoming like very, very small. Okay, so very, very small. But if you approach from the right side, they'll become very, very large. But otherwise, all the other values you will get. Okay, so sin x by cos x is going to give you all the real values. It's just that around integral multiples pi by 2, so there is a discontinuity. Are we okay here?
Yeah.
Okay. So again, look at this graph. Now, how do you think, okay, domain, again, domain, all real values are acceptable except wherever cos becomes 0. The range is the real number line. Okay. But there is a difference here. Unlike the first four functions that we saw, the period is different here. So the period is pi, because you see the pattern is getting repeated every pi radians. You guys see this? So let me highlight here. Between minus pi by 2 and pi by 2, you have a pattern, right? And after that, between pi by 2 and 3 by 2, 3 pi by 2, you have the same pattern. And again, 3 pi by 2 and 5 pi by 2, you have the same pattern. So every pi radians, the tan x is giving you the same set of values, basically all the real numbers. Okay, it's going to give you all the real numbers. Fair enough, guys.
Yes, sir.
Now again, I want you to spend some time on this and then see why it is giving all the real numbers, because your sign can go from, let's say if you're on the positive side, it can go from 0 to 1. As sign increases from 0 to 1, cos is actually decreasing from 1 to 0. Okay, so that is the reason why you will end up having all the values. Okay, now cortex. Cortex kya hai? Kind of, it's a similar to your tan x. I can say similar, but it's a little different because here pi by 2 is okay because your cortex is cos x by sin x. Here the trouble comes when sin x is 0. So you see that the breaks are happening around 0, pi, 2 pi, minus pi. So there you have those breaks. Okay, other than that, all the real values are given by this function. Okay, fair enough. So here again, if you look at the domain is all real values are fine, but wherever your sin x becomes 0, which is n pi, that is not allowed, and the range is real, and the period is pi. Okay, guys, I know this is too much to take in, honestly, but how are we doing?
And okay.
Harsha, understood?
Not really, sir. Not.
Okay, now ask me, what is that you want me to explain?
Sir, period, sir.
Period. Okay. So we'll do one thing. Okay. We'll go to sine and tan and then understand period, or we go to sine and then understand period. We'll start from sine. Okay. Harsha, look at this. I'm taking a unit circle. So the radius is 1. This is 0. This is your x-axis, origin here, and then y-axis. If I take a point P, what am I saying? If this point P's angular position is x, okay, so that x in radians is the input for sine and cos functions. Now, by definition, what is a cos function? It is giving us the x coordinate. What is a sine function? It is giving us the y coordinate. Now, what I want you to do is pay attention only to sine x. Okay, so pay attention only to sine x. Okay, so pay attention only to sine x. So sine x means sine x gives value of y coordinate. This is what you need to understand. So sine x gives value of y coordinate. Because sine x gives value of y coordinate, as this point P goes around the circle. Now let us start from x being 0. Okay, so if x is 0, you are here. Understand, Harsha? So now when x is 0, sine x will be 0. Now, when x increases, let's say the point goes here, goes till here, goes till here, and then it goes on. Now, look at the y values. Okay, so y values are given, you can just drop a perpendicular, right? From here, you can drop a perpendicular, and then that gives you y values. Now, do you see these y values will increase slowly to 1? And then what will happen? As the point moves around the circle here, the y values will drop. Okay, so y values will drop. Now, what you need to understand is your y values will go from 0 to 1, and then again they come back to 0. Okay, are you okay so far here, Harsha?
Yes, sir. Yeah, okay.
Okay, so now, okay, so when, let me put it this way. Okay, so when x is between 0 and pi, okay, so when x is between 0 and pi, I can include this. Your sine x Or maybe I think we should break this a little further. Okay, let me break it a little further. Sorry, why is it not erased? Let me break it a little further. When x is between 0 and pi by 2, your values, sin x values are becoming, let's say, they're between 0 and 1. And when x is between pi by 2 and pi, your values are going from 1 to 0. Okay. So I can write it this way now. I will have to write greater than. Okay. So sin x. And then this is greater than 0. You're okay? Now let's look at what is happening on the other side. Now, when the values are becoming greater than pi, greater than 180 degrees. So now look at these points. So what are the y values that you get here? The y values are all negative. Are we okay? Y values are all negative because sine is giving these vertical distances. Okay. Now what will happen? Right here it is 0, but as it comes to this point, y value is becoming -1. And again, from here till here, okay. So from this point, what is happening? So from this point, from here to here, you are going from 0 to -1. So that means you are actually decreasing in values. Okay. And again, from -1, if you're going till here, you're going from -1 to 1. So, sorry, -1 to 0. So they are increasing. So now if you take one complete cycle, let's say, if I draw the graph, this is x, and this is y. So let's say you're going from 0 to pi by 2, and then again pi, and again 3 pi by 2, and then 2 pi. So what is happening here? When you go from 0 to pi, your sine values are increasing from 0 to 1. So they increase like this. So they become 1. So this is 1. And from pi by 2 to pi, what is happening? Your y values are decreasing. See, these are dropping. Okay, so they're becoming smaller in height, smaller in height, smaller in height, smaller in height, and then almost 0, right? So this graph will go and then meet x-axis 0. But after that, what is happening? You are getting into third quadrant and then fourth quadrant where your y coordinate is negative. So the height, these heights, they are actually increasing, but they will be taking values with a minus sign. So that means you are actually going down. Okay, the values are decreasing. So now the graph will be below x-axis. Okay, it will go till here. So this value will be -1. And after that, what is happening? Again, the lengths of these vertical lines, they are becoming smaller, smaller, and then getting to 0. But again, till they become 0, they are still negative. So क्या होगा? अभी ऐसे इधर तक. But does the story stop there? The story doesn't stop there, because now what am I saying? You can actually go around the circle any number of times. Okay, so any number of times. So now after 2 pi, what will happen? 2 pi plus pi by 2. So that will be 5 pi by 2. And then again another pi, so 3 pi. And again 3 pi plus pi by 2. So that will be 7 pi by 2. And again 4 pi. Now, do you see, Harsha, the pattern will start repeating? Okay, maybe I'll use a different color. Maybe I'll do one thing. I'll use yellow here. Why is it no sense? What happened to my battery? It's there. Okay, yeah, it's writing now. So now I'll use a different color. So now it goes to again +1. Again, it will drop. Again, it will go to -1. It will come. Now, do you see, Harsha? Every 2 pi radians, you get the same output from sine.
Yeah.
So that is why we are saying the period is 2 pi. Period का मतलब क्या है? What is the minimum, let's say, input values? Here X values that you need to check so that the pattern repeats itself, so that the output values are same. Okay, are you okay?
Yeah, sir. Okay. Got it.
So the same thing we will be doing for cos. Okay, so shall I do the same thing for cos, or you get the idea?
No, sir, not required. Got it.
So cos के लिए what do you do? Cos के लिए you are taking the x values, horizontal values. So they repeat. But yeah, tan के लिए now you'll have to take these values and then divide by cos, and then see how values change. I think I'll do one thing. I'll just explain how your tan changes. So that will be interesting. Okay, so let me explain. Okay, now let's look at tan. Okay. Okay, so this is x, this is y. Let's say I'm picking a number here, a point here, and then this is x. Your tan x is sin x by cos x. Now think about it. When your x is very close to 0, what will happen? Your vertical height. Okay, so you are basically dividing by this vertical height gets divided by the horizontal distance, right? So this is your cos, this is your cos, and this is your sine. When x is very, very small, your sine is also very, very small, even though your cos x is very large, which is 1. So that is why when you actually start off from 0, so this is x versus tan x graph. You start from 0, you will be very close to 0. Okay, but now understand this. When you hit pi by 2, your cos becomes 0. That is not acceptable. Okay, so that means because your cos is becoming 0, if you are to the left of pi by 2, the values should become very large. So we know that, okay, so they become like very, very large. But now, how do I really go to that value? To really understand that, you need to see what is happening in between. Okay. Now, let's take few values of tan. Okay, few values of tan. What is tan 45 degrees? Guys, tan pi by 4. What is that?
What's a tan 45 degrees?
Tan 45, yeah.
1, sir, 1.
1, right? So now tan pi by 4, it's like somewhere here. Let's say 1. So this is pi by 4. Now understand this. When x is actually less than pi by 4, can I say your sin x is actually smaller than cos x? Can I say this? Why am I saying this? If you take 45 degrees, let's say in a circle, if you take 45 degrees, it suddenly stops sensing. I don't know what happens. It's charged. So if you take 45 degrees, let's say, if this is 45 degrees, if you are below 45 degrees, what will happen? Your x coordinate will be larger. Do you see that? अगर यहाँ पर एक point ले लिया, आपका जो x value है वो ज़्यादा होगा y value से. अगर if you go to a point which is greater than 45, आपका y value ज़्यादा रहेगा rather than x value. Okay. So when x is less than 45 degrees or pi by 2, we can say that your sin x is smaller than cos x. Agreed? Harsha, you agree with this?
Yes, sir.
Okay. Don't worry, beta. These are not easy stuffs. Okay. You have to be brave. Okay. So x is greater than pi by 4, suppose. Then can I say sin x is greater than cos x? You're okay?
Yeah.
Okay. Now your tan x is what? Your tan x is sin x by cos x. We have written here. So when you are less than pi by 4, what will happen? In the numerator, you have a small value, and in the denominator, you have a large value. Okay. So that means you will get a number which is smaller than 1. Agreed?
Yes, sir.
Okay. The moment you cross pi by 4, what will happen? You will get a number which is greater than 1. So you should see some values which are smaller and then greater. You get the point.
Yeah.
Okay, so now that is why you will go to 0 and then you will go climb like this. And again, I'm drawing approximately. The software will give you a better approximation. So यहाँ पर भी कुछ -1 होगा, ऐसे होगा graph. You get the point. That is how the tan graph looks like.
Yeah.
So this is minus pi by 2. Minus pi by 2 पे very small हो जाएगा, plus pi by 2 पे very large. Okay, again, see, we can revisit these graphs again in another class. So what I will do is, I think, go through these graphs. Maybe we will revisit this again. So first time ke liye, yeah, this is too much. You have been brave. Om, are you okay?
Yes, sir.
Okay, Sudhanya, how about you, beta?
Yes, sir. I'm understanding it better.
Understand better? Okay.